Good morning, everybody. This presentation is made by me, Jonathan Kohler, and my co-author, Clemens Brouwer, is also associated with this work. What we're going to talk about now is modeling digitalized logistics systems and agent-based approach. This is part of the EU Horizon 2020 STORM project, Smart Freight Transport and Logistics Research Methodologies. What we have done is an extensive exercise to find out about what's going on in freight transport and what the future of logistics and freight transport might be. There are two main areas where logistics is undergoing structural and probably system change: decarbonisation and digitalisation. And this has led us to look at what current modelling in the transport field does and how we think it might be expanded to accommodate changes in the structures of logistics. What's missing, we feel, is that there are no real plausible projections of how logistics structures will change into a digitalized low carbon form. What is missing then in modeling is scenario simulations of how these system changes, these interlinked system changes between digitalization and zero carbon energy might play out. A consequence of that is that we do not yet have policy package simulations that will actually deliver sustainability. Do we need to consider demand management in particular, or scenarios of lower growth in freight transport? These are things that are currently missing. So our proposal is just one way of approaching what are very broad issues. And in our modelling, we have used in the past for transport, sustainable transport, the Matisse model, and used it in combined qualitative, quantitative analyses of transition pathways. The approach that we take is a combined stakeholder modelling approach, which involves the 4 steps shown here. Firstly, you consider the generalized factors that are driving change, the so-called social, technological, environmental, economic, policy, and logistics factors. You choose a long list and then in consultation, ideally with stakeholders, prioritize this to key factors. These key factors are then used to develop future assumptions out into the future for 2030 and 2050, typically in our work. These assumptions should then be validated by experts, and then they are used to build qualitative scenarios. And these qualitative scenarios are built up out of consistent combinations of the key factors. So the key factors might have different outcomes, and different outcomes such as a strong policy and a rapid technological change will then be part of a scenario that expresses a change in society where the environment is important, digitalization takes place, and the solutions to low carbon futures come about through digitalization and new technologies, for example. These scenarios are then used in a quantitative scenario simulation, and in our work we use the Matisse model, which I shall talk a little bit more about in a moment. The model needs then to interpret these qualitative factors and put it into its parameterization, and then you can do your simulation and policy assessment. Just a few words about the structure of the Matisse model. It implements the so-called multi-level perspective on transitions, which views changes in society and so-called socio-technical systems as interactions between 3 aspects of society. Firstly, well, at the highest level, the landscape, the macro level of general structural, social and cultural change, issues like climate change, political instability, globalization, which affect people's everyday lives in many different ways. Then at the meso level, there are socio-technical systems that already developed, the current transport system with fossil fuel powered vehicles and third-party logistics and lots of distribution centers and centralization through Amazon, Chinese ownership of Rotterdam, etc., etc. And that's the regime. And then there are alternatives which could be different, very different, and these are the so-called niches. And the regime and the niches interact. They may compete, they may combine to address changes that come upon them from the landscape, either through scientific change, like new computers, new digital systems, or from society saying, oh no, I'm afraid you can't use fossil fuels anymore, you've got to do something else. In the Matisse model, these socio-technical systems, the regime and the niches, are influenced by the decisions of logistics companies. And logistics companies decide which type of technology and structure of system they're going to use. This is, of course, simplified because big logistics companies will do lots of different things. But in this way of viewing things, you can either go with a regime, keep doing what you're doing, or you can adopt a niche of, let's say, low carbon hydrogen supplied lorries and a logistics network that reflects that. Or you might have a niche in blockchain-based direct peer-to-peer consumer delivery, or you might have localized production as opposed to globalized production. These could all be niches as opposed to the current globalized supply chain view of logistics, the regime. What do these ideas for new niche systems imply, and how might they be implemented as logistics organizations and structures? There are various ideas out there in the literature, and we try and summarize some key ideas here in this slide that we would like to try and model as potential niches in the Matisse logistics model. Quite close to what's going on now, and in a way a linear development, if you like, of current systems is the concept of logistics control towers, where you assemble all the information over a supply chain in one place, or at least in one internet platform. And this should enable you to coordinate along the supply chain and improve efficiency. And the idea here is that you don't manage each link in a supply chain separately, but you look at the whole supply chain, optimize your warehousing and your transport for the various stages of production and delivery to consumers. And hopefully that will improve efficiency. If you can do this, you also have the opportunity to measure and reduce emissions more effectively, because you can know what modes are being chosen, how far they're driving or traveling, and then measure accurately the activity. So that's one possibility. Another possibility is a widespread adoption of blockchain and big data analytics, which enable, we would argue, adaptive decentralized supply chain networks. And the point here is that if you have automated data management, you do not necessarily then need to go through one big internet logistics portal. Instead, you can use search engines across different portals, and this could, in principle, decentralize the provision of logistics and enable lots more point-to-point structures as opposed to the hub and spoke networks that we see, especially in container movements these days. Another point about blockchain is that it is supposed to enable smart systems, smart contracts, and ease data exchange. And this is a fundamental part, in our opinion, of the ideas, or in implementing ideas around so-called synchromodality or the physical internet. Synchromodality is the idea that you have not a linear supply chain, but you have a logistic supply structure which consists of lots of intermodal nodes, both for production, final distribution, and intermediate links in this network. And you send your consignment off in one mode, in one direction, and in real time you optimize how this product or consignment will get to its customer. In principle, you could just do that with road lorries, but if you have very low costs of cross-docking and you can avoid long delay times in warehousing when you change modes, then you have got a much more flexible system, and you can allow for motorway accidents, uncertainties in weather, etc., etc. And the critical point here is that the transport system is then no longer organized as with logistics control towers with a management over a whole supply chain, going from raw material extraction to end consumption with a series of production chains, production steps in the middle, each connected by a transport link in a transport chain, in a supply chain, but that you have a producer, they have customers, and they send their goods out, so that in one sense is the same, but they don't necessarily know how it's going to get there, in the sense that they just send their container. It is guaranteed, there is a contract which will get it to its end customer, but there is no predetermined organization dimensions that will reflect these new aspects of the new niches. And we list some of them finally here, that we are thinking of ways of characterizing these potential new digitalized low carbon systems. One aspect is concentration level and coordination versus competition in third party logistics. How widely will blockchain applications for smart contracts and secure data exchange be used? Costs, of course, investment costs of new digital infrastructure and systems. What sort of structure of business to consumer markets might be? Will there be mass production to centralized distributors? Will there be mass individualization of production and decentralized supply chains? And if there are decentralized, or to what extent are there decentralized supply and distribution channels? And what are the differences in shipping and stock holding costs versus delivery times that are down to possibly less than 2 hours? Also, decarbonisation will require incorporation into the decision-making process in the future. So greenhouse gas emissions of the transport supply chain, both in the EU and internationally outside the EU, given the globalised nature of current logistics, will be required to be modelled. And as well as the investment cost of new digital infrastructure and systems, there is also the investment and operational cost of vehicles and with alternative powertrains and fuels. And one aspect that needs to be considered with the new low carbon fuels specifically, we believe, is the infrastructure for the fuel supply, because there may well be issues around range, in particular for road vehicles with synthetic fuels or batteries or power cells or whatever. So this is just one proposal given our experience in modeling system change and transition change in mobility. I would like to emphasize as a last point that there are many, many, many other ways of looking at these issues, and in particular, large-scale agent-based models with large-scale data sets we think are a way ahead in the future. That is, we're seeing that already to a certain extent. That's one thing. And there are then issues about data simulation, obtaining data, how you manipulate the data, and how you actually can model it. Another thing which seems to us to be important is that you, in addition to the physical goods and the economic aspects of transport, we believe that data exchange will become so critical for new logistics systems that you have to model that as well. And this takes you into a whole new form of modelling, we believe, which is not part of current transport models, certainly at the EU policy level. So you would need a sort of combination model of both freight transport, physical activity, prices, but also the information flows that go with it. So that's how we think the future of freight transport modelling could go, and we look forward to seeing its implementation. Thank you very much.